Hello, my name is Dietrich Schmidt and I am from the Fraunhofer Institute for Energy Economics and Energy System Technologies in Germany. And it's a pleasure to me to present you here the work on the digitalization of district heating and cooling systems. This presentation is a presentation of the international collaboration activity EI.A DHCTS1 with the same title, Digitalization of District Heating and Cooling, Optimization and Maintenance of District Heating and Cooling Systems via Digital Process Management. If you want to know more about this particular activity, please go to the homepage indicated here. So what is the goal of this large collaboration activity, international collaboration activity? What is the goal of this project? First, we want to create awareness of the advantages of the implementation of digital processes to the various stakeholders and users. Secondly, we would like to provide a state-of-the-art overview of the digitalization of district heating schemes in terms of R&D projects, of demonstrators, and also on case studies. Third, we would like to evaluate non-technical barriers and enablers for digitalization processes in district heating and cooling schemes, such as business models, legal aspects, and policy instruments. Especially the last ones, the legal aspects and the policy instruments, is quite important, and also the business models is quite important to get more digital process management into the real systems. I'm quite sure that you all know this ESCAM model, where you have the different layers, the domains and zones where digitalization takes place. So we can here from the generation to the customer premises, the different domains, we have the different zones here from the process, from the actual process where things are really happening, up to the market interaction, and the different dimensions from the component level, component layer, where the different components are collected, up to the business layer, where the actual business is managed for the different digitalization processes. So this is the overall concept, and we used it also for our action, but we just took parts of this different model to analyze more in detail and to work more closely with the digitalization of district heating and cooling schemes. And I'm going a little bit more in detail in the next slides. So the first part is digitalization of the end use, the consumption, or maybe in other words, the digitalization of the secondary side of a district heating system. Here is really it's really the beginning and the basis of the optimization of district heating schemes. So we need to make sure that the buildings, the consumers are working so-called correctly. So by optimizing the secondary side via digitalization measures, we could reduce return temperatures and we could reduce peak loads, and thereby also being able to reduce the supply temperatures, which is quite a big step for optimizing district heating schemes. So there's a large potential, as the actual heat demand is normally much lower than the design load. Secondly, we can develop a strategy for building service packages, so we can define the potential for lowering the temperatures within the particular building. We can stimulate the use of all radiators and thereby reducing return temperatures to the district heating grid. Via data mining, we can identify anomalies in the space heating operation, and we can troubleshoot and improve the hydronic balance of the entire system. So there are various possibilities how and what we can do for optimizing or for being active on the secondary side to do something good for the overall operation of the district heating system. The second step is the digitalization on the system perspective, taking into account both the secondary side, the demand, the distribution, and also the generation part. And here in or having the view, the bird's view on the system perspective, we have also two different possibilities. One is the operational optimization, where we directly work with the control schemes and do something online. So we can modify directly the control of temperatures and flows to optimize the system. And here the objective is to optimize, of course, the system. The objective is on the network scale to optimize the system here. On the secondary, or the second part is the analytics, diagnostics, and we do that offline. So it's not a direct active intervention, but we do analysis with large amount of data and calculating new set points and doing analysis on that level and mirror that back on the on the second part. Our third focus area is the digitalization of the infrastructure. Here we work very much with the concept of digital twins. And here the possible use cases of digital twins are the optimization of operation and control, fault detection and diagnosis. We can also work with the digital twins to do scenarios, what if analysis, and we can also use digital twins to do predictive maintenance and the asset management. Last but not least, digital twins are often used for visualization or virtualization of systems, of larger systems. Here we were working very much with these systems and also studied very many case studies where digital twins are used. The fourth and the very important part is the digitalization of business processes. Here the core issue is to examine the cost drivers for operating and maintaining district heating and cooling networks, and thereby qualify the economic potential for improvement based on tools and insight provided by digitalization. This is also meant to use best practice example to be included here to give a proof and to validate the return of invest model. So it's not only to do on the technical part, but also in the economic part, the digitalization, and to evaluate the economic possibilities and challenges here. The second step for the business processes, we were also quite keen to develop and to collect new ideas for new potential business models which are enabled through digitalization. So by collecting a large amount of data, we can think about new business models. Just coming to the first conclusion, on a general level, we can say and we can state that digital technologies are believed to make the whole energy system smarter, more efficient, more reliable, and to boost the efficiency and also the integration of more renewables into the energy system, and especially here in this case into district heating and cooling systems. In more particular, that means in future, digital applications might enable district heating systems to fully optimize their plant and network operation while empowering the end user. So it's not only the technical issues here, not only the technical optimization, it's also with the business models and how to integrate the users and all actors. For wider integration of digital processes, challenges such as data security and privacy, as well as questions about data ownership, need to be handled and solutions need to be worked out. So we need to be sure that we work on a safe ground with all this data handling. A key question is where in the way from the buzzword digitalization to real business models, products and market-ready services goes. So it's not only to indicate something fuzzy that digitalization is something modern. So we have to really think about how to integrate it into the market and make market-ready services. The particular strength of this presented project here is a very close exchange between the system manufacturers, utilities and service providers with the research community. And so I'm quite happy to announce that the final report from this action is published or had been published via the German Heat and Power Association. So it's about 160 pages in 13 chapters. We had 35 authors helping us to finish this report. And if you like, you can scan this QR code and you get your PDF directly. Thank you very much for your attention.